In this problem, we want to find the absolute max and min of this function, which happens to be graphed over here, over the indicated interval. So you can just kind of look at the graph and estimate, or maybe even get it completely correct. But you need to be able to do it the calculus way. So the calculus way is to find the critical values and then determine whether the absolute extrema occur at the critical values or the endpoints by comparing y values of those x values. Okay, so first we need the derivative. It's going to be 2 minus 4x. Critical values occur where this doesn't exist, which this is a simple line, so it exists everywhere, or where it equals 0. So we get x is 1/2, and that does look like probably right there is that little maximum that x is 1/2. So that looks correct. 1/2 is in between 0 and 3, so we're going to determine where the max is by plugging into f of x, because we want to compare actual y values on the function at the two endpoints and the critical value. So f of 0 is going to be 2. F of 1/2, let's see, that'd be 2 plus, right here, 2 times 1/2 is 1, minus 2 times 1/2 squared is 1/4. So that's 3 minus 2 1/4, just kind of doing the fractions in my head. 3 minus 2 1/4 is going to be 3/4. It looks about like what I'm seeing on the graph there. And f of 3 would be 2 plus 6, right here, 2 times 3 minus 3 squared is 9, times 2 is 18. 6 minus 18 is negative 12, plus 2 is negative 10. So clearly negative 10 is the lowest of these three values, so that's the absolute minimum occurring at x equals 3. The highest of these values looks like it's at f of 0 is 2. I want to check this one again. Times 1/2 squared is 1/4. That's 2 minus 1/2. I don't think I did that right. This just doesn't, I was thinking this doesn't match the graph. Let's try that again. So 2 plus 2 times 1/2 is 1. That's correct. 2 minus 1/2, or 2 times 1/2 squared. 1/2 squared is 1/4. Times 2 is 1/2. Let's try this again. 2 plus 1 is 3. Minus 2 times 1/4 is 1/2. There we go. That's 3 minus 1/2 is 2 1/2, or 2.5. That makes more sense. And it does look like the peak is a little bit above or past x equals 0. So that's actually our maximum.